Good afternoon, everybody. Thanks for having me. My name is Victor Cassella. I'm a meteorologist. I work for no luck. Try and do it that way. I work for HydroMet. I've been with the company now for 18 years. Prior to that, I was working for the Department of Energy at Brookhaven National Laboratory, a nuclear facility. My background is in forecasting as well as emergency response. But who is HydroMet and what do we do? HydroMet is the name of the company, and we own several manufacturers. And these manufacturers, I'm going to start in Germany. Ott, if you're familiar with them, the maker of the pluvial rain gauge, the weighing bucket rain gauge. They've been making these buckets for 50 years plus. We are with every Met service that's in the world, and they are accurate down to, I'm going to talk imperial units, down to the thousandth of an inch. Also throughout, we have distrometers, they're called the Parsible. They measure the particle size and the speed, and they have a visibility sensor on there for your local networks. It also makes pressure transducers and bubblers for flood monitoring and water heights. Staying in Germany, we have a company called Luft, maker of barometers, wind sensors, solometers, road sensors to monitor that may happen on the road. I know you don't experience this, but you may have snow, sleet, hail. This is what they measure for the transport industry. Also with Luft, they make sensors for line rating analysis. How much power can you put through your power lines? The more power you put through there, the hotter the wires get, the more they sag, they could snap. So we make the devices that can give you the warnings, early warnings, so you know when to not produce so much energy on these lines. Going a little further north, we go into Holland. This is the company that I came from, Kippenzonen, makers of solar radiation sensors, right from the UV, shortwave, the pyranometers, long wave, the infrared, the pyrgeometers. Tracker systems to monitor the sun from sunrise to sunset. We make scintillometers that would agricultural side for crop production and water management. The other part of it is now very popular is laser communications and with telescopes, because the more aerosols you have in the atmosphere, they create these distortions and your instruments will not work as that well. So the military are using these sensors, to monitor the atmosphere in their vicinity where the lasers are going. And then the big part about Kippenzonen is solar renewable energies. We have power plants, but we do have the device plants for solar renewables that much more effective. How much power is hitting the panels? How hot are these panels getting? Bifacial, what's the reflective part coming from the Earth's atmosphere hitting the back of the panels? These how dirty the panels are. We make dust sensors that monitor the dust level that goes on top. So these are the instruments that we have for this type of industry. Coming to the US, going out into Colorado, Loveland, our hydro lab portion is making sondes that measure the water quality. And we have a couple on our booth in the back, and we can go over it. They're customizable for fresh water or salt water. Also staying in Colorado, our forecasting side, Meteostar, which is a company that brings in all the weather data together and can give weather forecasting for your needs. Transportation. It's a service that we offer. And then coming on the East Coast of the United States, a company that I know you all know is Sutron. And Sutron brings all of this together, and they could package into a simple device like we have on the back in the tripod, or a fully implemented weather stations that could airports, 10-meter towers, um, National Weather Service, USGS, to name a few that I'm familiar with, that we have to monitor water heights, wave heights, any weather that's coming in. Uh, Okay. So to summarize it all up in a nutshell, the services that we offer is we're going to talk to our clients. We have integrators, we have channel partners, and then we also work with the individual countries and just municipalities. You tell us the needs, and then we can customize the stations that you want to implement, whether it's a small flood monitoring station or a full-fledged AWAS weather station. We will help with the installation, the operation, the training, supporting your needs. And if you need us on site, we are there. We have offices all over the world that can support these needs. We have the software behind it that you could get this data, and we can create the databases. It could be on an app, right at your fingertips on your computer desktop. Um, we also have a company that we partner with called Aqua Informatics. It's called AQI. And they're a service that can bring in all sorts of data from all agencies. And they're the AI behind it, where they'll QA the data and make it accessible to your needs. Sutron, through the data loggers, is the communications part. How do you get that data back to your facility? Is it just by spread spectrum radio, networking, cell phones, or even satellite data? We have the instrumentation to do that. We have the SatLink 3 in the back, which has the GPS modem right directly into the data logger to make it seamless for the data communication. And the part that's really dear to my heart is the monitoring side, the sensors. That's where I love to talk about, get involved with the research side. Um, you want to measure delta T, we have the instrumentation for that. If you want to measure hurricane force winds with a sonic anemometer that's going to reach 90 meters per second, we'll work with that. One of the questions that comes up to me, how strong is your sensor? Will it measure the 90 meters per second? Absolutely, it will, but we can't stop the flying debris in the air that's going to hit this sensor and break it. That's why we recommend redundancy at your site, at these sites, if it's really needed. And an overview of some sample stations that we have. On the left is a standard 10-meter tower with winds, with everything that's needed, all redundant on there. This is, I don't know which island this is, but we've built for the New York State Mesonet. I don't know if you ever heard of it. We did 140 of these stations. They're all run by solar panel and batteries. They all have redundant sensors on it, and the data is all public. They want to sell the data to pay for the site. As you all know, it's very easy to buy the equipment. The hard part's maintaining it over the years. And that's what we try to help, is to create high quality equipment that doesn't break down, support system that will support the parts that need it, so you don't have to replace the equipment. That's the goal. Going counterclockwise from left to right are the different type of water quality measurements that we have, whether it's on streams or ponds to measure the water heights for flash flooding or any type of emergency that may happen. And in the middle, I talked about, this was in Trinidad. I have the sensor in the back. It's a nitrogen plant. And at the top of that stack, there's a flame. And that flame is on 24/7. They needed Kip and Zonin back in 2012 to come in and to, for emergency reasons, monitor that flame so it didn't go out, so there wouldn't be any nitrogen gases leaking into the vicinity, creating a massive potential of hazard for the people in Trinidad. We installed 12 of these on the 12 stacks, and it always gave a constant output on the voltage. So instead of looking at the sun and seeing 1,000 watts per meter squared, this was looking at the flame and getting about 50 to 60 watts per meter squared. And now they would know right away that there was a potential incident and they could turn off the gas. This way everybody was safe. And this is where we come in. We would like to come in and you tell us the scenario that you have and we can customize the solution as best we can. If we can't, we'll work with the players in the field and make our recommendations to somebody else that can actually do that. Um, and I, I know we're all pressed for time. Yeah, that's why I was told to keep a little quicker. Me and my colleagues are in the back to help you out, but I was listening, the panel this morning. I really enjoy listening to them. I started in 1990, and my first job at the nuclear facility, the meteorologist on call there started in 1947. And he came up to me, called me the college kid. Come here, what do you know? Could you give me the LOW forecast? He let me sit on this thing for about 2 weeks. I didn't know what that was. I didn't learn that in school. I called up my professors, my colleagues, and then one day he took me by the back, and then back then you were allowed to do that. And he walked me over to the window and he said, give me the look out the window forecast. So earlier on, we were talking about computer models and emergencies. You know, the climatology, knowing the region, knowing storms, makes us all better as a forecaster, for that we have to support in the area. So any questions? I will be in the back.